Thanks a lot for the invitation to give this paper. The paper is slightly different from the one that was originally announced, but the one that was originally announced is in the midst of a major revision, so I prefer to play it safe.
It's another mutation.
It's another, yes, it's a big mutation. And so that's the first thing. So this is a paper with Davide De Bortoli and Luca Gambetti, which we gave about a month ago at the NBR Macroeconomics Annual. And let me say that it's not an expectations paper, and less so a paper about deviations from rational expectations, but still it's a paper in which expectations play a very important role, I would say, in the in the main argument. And okay, so let me get started. So the motivation for this is straightforward. As you all know, central banks responded very aggressively to the recession and the deflationary pressures generated by the financial crisis, and that led policy rates in many advanced economies to hit their zero lower bound or their effective lower bound. Okay. So as a result of that, and given the desire to further stimulate the economy, many central banks adopted what has become known as unconventional monetary policies, including QE or some form of QE and forward guidance. Now, so a question of interest, both from a historical perspective and looking ahead, is to see how effective these unconventional monetary policies have been. Okay, and in particular, how effective they have been at getting around the zero lower bound constraint. So we adopt a particular perspective on this in this paper, which I think complements the existing literature, by focusing on what we call the ZLB irrelevance hypothesis. Okay, so this hypothesis can be formulated in a simple way. Okay, it's a hypothesis that the performance of the economy in a given country, in a given historical period, and so on, has not been affected by a binding ZLB constraint. Okay, which is very different from saying that we can ignore the ZLB constraint in our models and in our optimal monetary policy analysis. No, it's an empirical question as to whether at a particular time and place, in this case in the U.S., around the period where the ZLB was binding, which is 2009, 2015, the economy behaved as if there was no ZLB. Okay, so that's the question. In particular, we focus on two dimensions of the economy's performance, for which standard models yield very clear predictions: the volatility and how the economy responds to different shocks. Okay, so in particular, we test we assess the hypothesis that the fact that the ZLB has been binding has implied no increase in volatility and no change in the way macro variables have responded to shocks. And this is indeed what we find. Okay, so we cannot rule out or reject, if you want, even though this irrelevance hypothesis. Okay. So the literature, I mean, as the number of papers that somehow try to estimate the effects and then of QE and forward guidance policies is huge. I won't try to give a comprehensive list. Now, most of those papers have looked at something different from what we're interested in. They have just asked the question, do QE announcements typically, or forward guidance announcements, have some impact on financial markets and or expectations, typically market-based expectations. And they typically use high-frequency data. Now there's a smaller set of papers that are more closely related to what we look at, which is the irrelevance for the macroeconomy as a whole of the zero lower bound. So let me just say a couple of words about those papers. So there's a paper by Swanson and Williams in which they look at how a number of financial variables, but in particular long-term interest rates, okay, respond to macroeconomic news during the binding ZLB period and before. And they compare those responses, okay? Of course, we know that very short-term rates will respond very differently because they are stuck at zero during the ZLB period. The question is whether other interest rates, and in particular long-term interest rates, respond differently or not. And they find that the responses are very much the same across the two, let's say, regimes. Okay, so that's one paper that is relevant for us. There's a couple of papers by Wu and with co-authors Xie and Zhang, which they use the so-called the shadow rate approach, which roughly speaking consists of using the information in the yield curve, the entire yield curve, and map it to what the equivalent policy rate would be in normal times. Okay. So when they do that, they show that this, and they call that the shadow rate. Okay. So this shadow rate, they show during the ZLB period has behaved very much like the policy rate would have behaved if the Federal Reserve in particular was following some standard Taylor rule. Okay? So again, suggesting that the yield curve has not responded very differently to developments in the economy. And then a different set of papers that are more model-based, like Cristiano, Eichenbaum and Trabant, and Gust and co-authors. They use an estimated DIGE model that fits the data well during the ZLB period, and then they run some counterfactuals. Okay, let's say, okay, so they estimated and simulated using with the ZLB constraint embedded in the model, and then they just get rid of the ZLB constraint and run a counterfactual and say, okay, how differently would the economy have performed if there had not been a ZLB constraint, okay, on the basis of this estimated model, estimated shocks, and so on. And here the responses, interestingly, are very different across the two papers. So Cristiano, Eichenbaum, and Trabant find that essentially, in terms of inflation and output, the behavior of the US economy would not have been very different, whereas Gust et al. Find a substantial difference in the performance. Though in both cases, there is a lot of uncertainty associated with this response, these conclusions, okay? Yeah. Oh, yes, of course, yeah.
Is there a difference in the way the policy at the zero bound is?
Not, I mean, of course there are differences. Now I may not recall exactly the.
But it's not.
No, not major, not major differences. They all use a standard Smets-Wouters type DIGE model augmented with a ZLB.
Don't Gust and others also use high order approximations? Perhaps?
No, but this is in terms of how they solve the.
I was talking more just about the policy.
No, it's very similar. I mean, the specification of the model, it's not that they make very different.
No, that's true.
And the two models are very conventional.
Right.
It's true that Gust and co-authors use.
In this case, it doesn't matter, especially with your discussion about uncertainty, volatility at the ZLB ends.
Mm-hmm. They are the ones who find that.
Yeah, in fact, they find
there's more yes, but more uncertainty also regarding.
More uncertainty in terms of the results, or more uncertainty in the sense of the ZLB?
More uncertainty in terms of the results.
Of the results.
Yes.
Just to understand where you're heading,
no, I'm just introducing. I'm just relating the. I haven't even started.
That the Fed does unconventional monetary policies so well that the economy behaves as if, or is
Yes.
it we have to throw out our models
No.
because they have counterfactual implications?
No.
No.
It's the first interpretation that I will try to provide some evidence for. Okay. So that's why I said it's very important not to misinterpret this irrelevance result in the sense that it's for a particular time and place, not a universal result. Okay. So again, so what do we do? Relatively two exercises mostly, okay, which to look at changes in macro volatility during the binding ZLB period relative to the non-binding ZLB period, using essentially the approach that other authors have used to uncover changes in volatility, for instance, associated with the Great Moderation period. Okay? And then we use a VAR approach with the time-varying coefficients to see if the response of the economy to shocks has been altered during the ZLB period. And throughout, we have a simple, very simple new Keynesian model augmented with a ZLB constraint that we use to interpret some of our results. Okay, and as a benchmark of what at least one theory says. Okay? Okay, so some of the statistics that I will show you are really straightforward. Okay, so here what you see here is the ratio of standard deviations in the ZLB period, it says 2009 Q1 to 2015 Q4, relative to the non-ZLB period, and that includes the pre-ZLB and the couple of years after the ZLB period. Okay, and okay, so a value larger than 1 implies more volatility during the ZLB period. A value smaller than 1 implies less volatility during the ZLB period. So in the first column, we include all the observations in both regimes. Okay, and you can see that there's nothing really. Only in two cases, the case of hours, let me say that we use the growth rate of GDP, the growth rate of hours, and then the GDP deflator inflation and the core CPI and core PCE inflation rates, always quarter to quarter. Results hold also if we use year-on-year variables. I won't show them here. And so you see, if the ZLB had led to larger volatility, we would see values systematically above 1, but we don't. The Great Recession, may complicate things in the sense, may distort our results. Part of by the Great Recession, I mean the recession period triggered by the financial crisis as dated by the NBR. Okay. Part of the recession falls in the pre-ZLB period. Part of the recession falls in the ZLB period. But in any event, it was a big episode, and it may distort things. So let's get rid of the observations associated with the recession, with that recession, and the results, if anything, are more surprising or more against the hypothesis that, or the presumption that volatility may have increased. This contrasts, for instance, with other episodes that people have, different economists have pointed to as showing changes in volatility. Okay, so this is the ratio of the standard deviation of all these variables in the post-84 period relative to the pre-84 period. Okay, there are large changes. That's what we call, that's why it's the post-84, no, the other way, pre-84 relative to the post-84, okay? So much more volatility in the pre-84 period, okay? So it's not that we don't observe, without going back to, to the 19th century, periods in which there has been a significant change in volatility. This formalizes, I didn't show any standard errors here nor perform any tests because I think this is a better way to formalize a bit this idea. So these are what Stock and Watson call volatility regressions. So here I regress for each variable. We regress the absolute deviation of each variable on a constant and a dummy for the ZLB episode. And in some cases, an additional dummy for the Great Recession, again, to control for the Great Recession. Again, if volatility had increased during the ZLB period, we would find here estimates that would be larger than, that would be positive and significant. And again, here we used a new West estimator for the standard error that corrects for serial correlation. And we don't observe that. In fact, there are some cases for these two variables, CPI inflation and PCE inflation, for which volatility seems to have decreased. Okay? And again, this is independent of whether we control for the Great Recession or not. So this is just a visual evidence that for what I just said, for these statistical results that I just showed you. Okay? So here you have GDP growth and inflation, and the gray area corresponds to the period in which the ZLB was binding. There is no obvious change in volatility across, between the gray and the white areas. And again, this contrasts with, say, if I go back, this picture starts in 1984, the beginning of the Great Moderation. Okay? If we go back further, okay, we start in 1960. Okay, we observe large differences in volatility, okay, relative to the subsequent periods. Okay. Yeah.
You try removing a trend from inflation because there's also a downward trend. When you look at post-1984, you compare the standard deviation, that's going to matter.
This is post.
So if we go back to the previous graph,
Yeah.
I'm probably excessively picky here, but if I look at movements at high frequency during the gray area,
yeah.
It's not so obvious that there is not change in the volatility. So when I'm trying to say that we compute the standard deviation of inflation from 1984 to 2009, you're also factoring in a little downward trend in inflation. I don't think it's going to change the results, but once you're in this business, you might want to look at things across frequency.
Yeah, we allowed for a different trends, but for a different means, but we didn't allow for a trend. Yeah, that's a good point. I don't think that's a big issue. Yeah.
Would we conclude the same thing if we looked at Japanese data?
I'll say something at the very end. We haven't looked at Japanese evidence, but
it seems like the exercises you will do will be more informative. I assume they have to have changed in Japan.
Yeah, I'll say something. One of our students, Shengliang Oh, has follow-up paper that looks at Japan. I'll say something, but let me wait on it. Yes.
Is the focus mainly going to be on volatility? Because what strikes me about the Great Recession is that there was this long slump where we had real GDP per capita below the previous peak for this extended period of time. And the ineffective, if the zero lower bound is effective, you would expect that to be reflected in a long slump. That's
okay.
Not just volatility.
So I'll show you more evidence than what I just showed you. But relative with regard to that question, it's a legitimate question, and we thought about this. It's important. I mean, we don't want to deny that there was a major recession and so on, okay, and a slow recovery, but the shock that hit the economy was arguably larger than the typical post-war recession. Okay, so that's what we would expect. Okay, so the question that we're asking is conditional on the shock that hit the U.S. economy during this period, the financial crisis, if you want. was the response affected, the response of the economy affected by the fact that the ZLB was binding. Okay, no, it's a little subtle, but and hopefully some of the evidence that I will show you, in particular the impulse responses, and relative impulse responses, that's what our emphasis is on, will address that issue. Okay, we know from, there's plenty of literature that suggests that recessions caused by financial factors or associated with financial crises are deeper and more protracted. The recovery is much more sluggish. This has not been different. Many of those recessions in the past associated with financial crises had those characteristics, even though the ZLB was not binding. Okay, so very good. So here is a simple, again, as I said, we're going to contrast some of our empirical evidence with some predictions of a very basic model. I'm not trying to be too quantitative here. So it's a new Keynesian model. Here you have the new Keynesian Phillips curve. It's a dynamic IS equation. And there is only one, there are two shocks, but they are all captured by this ZT here, which you can think of as a shock to the natural rate of interest. It can be a preference shock or some other underlying shock behind it. So this ZT has two components, rho and eta. So think of eta as being the usual recurrent demand shock. Okay, so it follows an AR1 process and so on. And then rho, you might want to think of it as a discount rate if you want. The rho in normal times takes a value, rho t in normal times takes a value equal to rho. Okay, think of rho being positive and equal to the usual discount, the steady state discount rate. But occasionally, okay, its value becomes much smaller and negative. Okay, rho L. Okay, and this follows a Markov process. So this is what will trigger the ZLB episode in the model, a realization, a low realization of this rho t. And then the central bank follows a rule that we want to think of being an approximation to a realistic rule. So it's a truncated Taylor type rule. Okay, think of this as the target interest rate, and then there is partial adjustment of the actual policy rate to this target interest rate, and it's truncated at 0. Okay, and then for reasons that may become clear later, we also want to bring into the picture a long-term interest rate, an interest rate on a long-term bond. So it's a bond that matures with a probability. It's a bond that pays one unit of account of the numeraire when it matures and nothing otherwise, and it matures each period with a probability 1 minus gamma. Okay, so the maturity of the bond, or the time to maturity, is a function of gamma. Okay, very good. Now we calibrate this simple model. These are standard values. Let me not even spend any time on those. Let me just say something about the exogenous processes. Because
This long bond maturing. Can you go back?
yeah,
So beta is gamma is the probability of mature,
that it doesn't mature.
but it hasn't.
So just a way, this is equivalent to another formulation of a long-term bond in which the bond pays a coupon every period, and the coupon decays geometrically. It's equivalent. They are equivalent. Okay, so here are the exogenous processes. So essentially we calibrate. This is all a bit informal, okay? But we calibrate the standard demand shock eta, so that during the non-ZLB period, okay, the standard deviation of output growth implied by the model corresponds to that observed in the data. Okay, so that's the recurrent demand shock. and then we calibrate the Markov process and the non-recurrent shock, so that in normal times, the average real interest rate is 0.5% quarterly, that is 2% annually. But then, occasionally, with some low probability, it takes a value of minus 1% quarterly, that is minus 4% annually. So it's a large adverse negative shock. That would be the implicit natural interest rate. And then these are the probabilities in the Markov process, okay? The probability of staying in normal times, if you are in normal times, the probability of staying in the low natural rate regime, if you are in the low natural rate regime. And these are calibrated so that the ZLB episode happens on average every 140 quarters. It has an average expected duration, that's important, of 3 quarters. And on impact, it leads to a decline in output of minus 4%, which is roughly the order of magnitude of the decline in output in US output during the Great Recession. Okay? The model is very simple, so there is no way we can match all the output dynamics, the macro dynamics during the Great Recession. We just to get a sense of the orders of magnitude. Okay, so let me show you some impulse responses implied by the model. So here, this is an impulse response to a recurrent demand shock, a recurrent adverse demand shock in the 2 regimes. In blue, when the ZLB is non-binding, and hence the central bank can respond to the adverse demand shock by lowering the short-term rate, okay, according to that rule. And in red, when the ZLB is binding, which prevents the central bank from lowering the interest rate further in response to this adverse demand shock. Okay, and not surprisingly, okay, this is well known, and I'm sure you've seen many exercises like this before. Not surprisingly, the response of output to this adverse demand shock is much larger in the ZLB period, and the response of inflation as a result is also much larger. And see how the long-term rates, okay, diverge in this case, okay. Here you may be surprised that the long-term rate goes up, but that's because because we don't want to have to deal with trends and things like that. We have the growth rate of output here. So when the economy is at the ZLB and it is hit by the shock, agents expect the short-term interest rate to increase more in the future eventually, and that leads to a positive response of the long-term rate. The long-term rate is assumed not to hit the zero lower bound ever in these simulations. Okay, very good. And here you have the relative volatility statistics that I showed you earlier for the data, but now these are based on simulations of the model. So we simulate the model, and so we simulate histories of the model with the same length as the length of our sample period, starting from 84, and we force those histories, when simulating the model, to have a ZLB episode of the same length as observed in the data. 28, I think it's 28 quarters. 7 years times 4, 28 quarters. Okay? And here you have the relative standard deviations that we estimated using the data and now using the model. Okay? And you can see that they are large and above 1 systematically. Okay, here we include all the observations. Here we exclude the periods in which there are the Markov transitions and in which there's a lot of disruption in output and inflation. Okay. So again, large differences with the empirical evidence. And here we run the volatility regressions using data generated by our model. The data these simulated histories. Okay, and again, this is the key estimated coefficient. There's a coefficient on the ZLB dummy. So remember, the left-hand side variable here is the absolute deviation from the mean of each variable, and we just regress that on a constant, a ZLB dummy, and in some cases on a Markov transition dummy. Okay, so we see that systematically this coefficient is positive, suggesting that volatility is measured that this particular way increases during ZLB periods, and this is the fraction of times in which we would reject the probability of rejecting the hypothesis of equal of a zero coefficient here. Okay, so even if the ZLB period is short, this was a criticism that we faced earlier when we were presenting this evidence, is that, well, the ZLB period is relatively short, so standard tests may not be powerful enough to detect a change in volatility. But we see here that at least when using the data simulated by the model, it is very easy to detect that change in volatility. Okay? And here you have a plot of one particular history for output growth and inflation with this based on simulations of the model, and you can see, and the tunnel, these bands are just the 95 confidence intervals of those variables at each point in time, and you can see how the volatility increases substantially during the ZLB period, okay, which is given by this interval here. Very good. So that's the first part of the paper. Now let me turn to the second part, which is where we try to answer the following question. Has the response of macro variables to shocks changed during the ZLB period? Okay. So here we follow an approach that I think was first proposed in a paper by Giorgio Primiceri. Essentially, we estimate a structural VAR, okay, but allowing for the coefficients to vary and hence to the impulse responses to vary over time. So this is a standard, this would be the reduced form VAR. So it's a standard VAR. The only difference with the one that we have all estimated at some point in our lives is that there are T subscripts in these matrices. Okay, so we're allowing these matrices to change over time. Not only that, but the variance-covariance matrix of the innovations, UT, okay, sigma, also has a T subscript, so it's allowed to change. And finally, we make the usual assumption when in structural VARs, namely that there is a linear relationship between these innovations, these reduced form VAR innovations, and the structural shocks, the underlying structural shocks, which are collected in this vector epsilon. Okay, there is a linear relationship, and this linear relationship is allowed to change over time too. Okay, and there's this condition that you can see this matrix Q has to satisfy. And so we are going to impose, as usual, some identifying restrictions to pin down this matrix Q, given our estimates of sigma. Okay. Now this slide just says there's a lot of yes. It's restricted by this. This is a variance-covariance matrix, and that imposes some constraints on Q. But other than that, there's no. Oh yeah, well the law there are some restrictions on, but not specific. We don't impose them on Q specifically, but on sigma. Okay, so and that, and these are the restrictions. So again, lots of notation to essentially say that all the coefficients in this reduced form VAR are assumed to follow random walk. Okay. okay? With innovations that are orthogonal among themselves and for which we impose some priors that are standard in this literature.
Sorry, I'm a bit biased here, but is this really like the best model to think about the CFP? So I think we have like a big shock in 2008 and then a drastic change. This is a model that is well suited to capture very smooth transitions.
When you say we have a big shock in 2008,
yes,
we're not ruling out a big shock in 2008.
The way these models work is that there is one matrix that controls the size of the innovations to the structural parameters. It's one matrix.
Oh, sorry. We're not ruling out a big shock, a big epsilon shock. In the structure, a change in the structure. Okay, not in the size of the shock.
Exactly. The size of the shocks to the parameters is fixed over time. And generally, I mean, you're capturing like these low moving trends that start in the early 80s.
So the question is whether a model like this could detect a change.
Yeah, it's going to have definitely a tension between capturing low frequency changes versus.
I'll show you some results, and then you could ask that question. Then say you have anticipated it. Yes, and then at the end, well, or when you should have asked the question, I will show you some. Other results of, I'll show you a counterexample, but again, just to not to break the logic of the, okay, but it's an absolutely reasonable question, okay. Very good. Now, I won't get into anything related to estimation, the estimation of the model. Well, once we have the reduced form VAR with time varying coefficients estimated, we have this, what you can call the corresponding moving average representation. And given this, we can recover the structural moving average representation, what we're interested in, because this shows how the different variables in X respond to the different structural shocks. So this is like a standard structural VAR. The only difference is that these impulse responses, which are the elements in this matrix, are time varying potentially. Okay, and we go from here to here using this restriction, which is implied by this. Okay, very good. So here are the variables that we include in the VAR and the identifying restrictions that we assume in order to go from the reduced form VAR to the structural VAR. So this is log output, log hours. So this is the growth rate of labor productivity. N is the log of hours. Pi is in quarterly inflation. GDP deflator we use for. And this is the long-term interest rate, the interest rate on a 10-year bond. And we use the long-term rate because we don't want to use the policy rate because we know it's stuck during the ZLB period. Okay, we don't expect it to change to any shock. But the long-term rate, particularly a 10-year yield, was never hit the zero lower bound. Okay, so in principle it can respond to any shock. And we use a combination of long-run and Sang restrictions, with the Sang restrictions imposed on co-movements between these different variables at 1 year horizon. So very quickly, we assume that technology shocks are the only source of the unit root in labor productivity. That is the only shocks that can have a permanent effect on the level of labor productivity. That's an assumption that I had used in earlier work. What we call demand shocks are the shocks that imply a positive co-movement, remember at 1 year horizon, without imposing any constraints, contemporaneous constraints, okay, in contrast with some of the literature. A positive co-movement among these three variables, output, inflation, and the long-term rate, and that's a very standard prediction of any estimated DIG model, for instance. Monetary policy shocks are the ones that generate a positive co-movement between output and inflation, but a negative co-movement with a long-term interest rate. Okay, because in this case, the response of output and inflation is generated by a change in interest rates, an exogenous change in interest rates, and to the extent that the long-term rate moves in the same direction as the captures the sign of this monetary policy shock, then the long-term rate will move negatively with output and inflation. And then what we call transitory supply shocks, you can think of them as markup shocks. For instance, price markup shocks are shocks that do not have a permanent effect on labor productivity, but they generate a negative co-movement between output and inflation. Okay? Very good. So this is the data. Everything is standard. I already mentioned the variables that we use. We end in 2015, the last quarter of the ZLB. And so the model, for those of you who are not familiar with this empirical approach, what this apparatus generates is an estimated impulse response for each period, for each quarter. Okay? So now there's no point in showing you hundreds of impulse responses here. What I will show you is the average impulse response of each variable to each shock during the binding ZLB period, and we'll compare that response to the responses in the pre-ZLB period, okay, to each shock. Okay, to be specific, to the 7 years before the ZLB became binding. And here we use the impulse responses during the 28 quarters, the 7 years, during which the ZLB was binding. So we use the same number of periods in both cases, okay? Okay, so here you have the impulse responses. In blue, you have the impulse responses in the pre-ZLB period, right before the 7 years before the average impulse responses in the 7 years before the ZLB became binding. In red, the impulse responses during the ZLB period. And then you see the 68 and 95% confidence bands associated with the impulse responses, with the blue impulse responses, the pre-ZLB impulse responses. Have the different shocks here: technology, demand, monetary policy, and transitory supply shocks. And here you have the response of output, the response of inflation, the response of the long rate, and the response of the long real rate. Okay, the response of the long real rate is the response of the nominal rate minus the implied estimated response over the next of inflation over the next 10 years. Okay, and so the first, well, I mean, we can look at individual impulse responses, but the first thing that stands out is that, you know, they are very similar across the two periods. There are very tiny differences. In particular, and that's what we want to emphasize, okay, and much of the evidence that I will show you next focuses on this, the response of the long rate to the different shocks, but in particular to demand shocks, okay, is very similar across the two periods. It looks slightly muted during the ZLB period, but it's not very different. And most importantly, I mean, that's the important qualitative result. The long rate goes down in response to an adverse demand shock. It's estimated to go down, okay? Significantly. Very good. So this, okay, so again, this compares these two subperiods. Now the Great Recession is in between, okay? That may mess things around. So let's get rid of it. So let's eliminate the observation or the impulse responses. When we compute those averages, let's eliminate the impulse responses that fall in the recession period. Before we do that, this is just the difference in the impulse responses together with the confidence bands for the difference. Okay, so we cannot reject that the difference is zero in any case. Okay, and here is where we exclude the Great Recession periods. And again, the results are similar. And here, just one further robustness test. Here we use a longer pre-ZLB sample, so we don't use the 7 years before the ZLB, but we use the whole pre-ZLB great moderation sample period. And we get very similar results. So now let me address your question. So one interesting question is, well, maybe this is somehow inherent to this empirical approach, and the smoothness in the coefficients that is again embedded in the approach that doesn't allow us to detect any difference. So that's one. Obviously, that's a possibility. So what we thought is, okay, let's apply the same empirical approach with the same identifying restrictions and so on to a period or to two periods for which we think, because of independent evidence, that there should be substantial differences. Because the way monetary policy was conducted. So we compare the early post-Volcker period with the pre-Volcker period. And we look at different sizes of samples and so on, but let me go to the very end because I have, okay? So, and again, and there's no gap between the two. And we've tried different alternative specifications. And we detect substantial differences, okay, in this case. So, again, we feel comfortable that it's not a necessary consequence of the approach not to find the small differences.
Why not do the whole sample then?
Why not do
Why not to do the whole sample? Because sorry, I mean, Jordi, I'm being a bit a pain here, but
no, you're not doing a pain.
I think if you,
we could do the whole sample.
The whole sample, yes. Because I mean, the reason why I'm saying is because this is the paper Jordi uses to show that there is no big change in monetary policy pre-post Volcker. I'm sure you don't like that result that much, but the same model, this one, the time varying VR. So I think
that there's no change in monetary policy.
There is nothing really going on in terms of the way impulse responses look like in the 70s versus trade moderation. That's the restart paper by Jordi, which uses introduces time varying VR. So there are a lot of things. For example, another thing I'd like you to show is what explains the Great Recession in this model. Is it because remember you have a time varying constant, and wondering if this time varying constant is capturing this Great Recession, then the way the Taylor-Rule coefficients look like becomes a little bit less relevant there, because you're basically capturing the big recession with the constant itself.
Yeah, I don't think it's the case. It's muchly a large. There's a large. Well, it's a sequence of adverse shocks of all types, but in particular demand shocks. But that's not something we have focused. We should show that in a picture.
Another way, could you simulate the model that you have with the zero bound period and then estimate the time value?
We did that. That's actually something we did. Though there's also a natural criticism of that. We removed it from the paper. We estimated the model and we applied the same method to the simulated data, and we found substantial differences. Exactly the same method. Now, the criticism, or what people argued then, and that's what led us to change this, is that somehow that simple model that we use exaggerates a lot the impact of the zero lower bound because it's very forward-looking and so on. No, and we don't want to get into that debate. I mean, I think it's a fair criticism. So here is another. Okay, had finished this. Here's another, the evidence that I like better, and I think it's novel in terms of the approach, but it complements what I just showed you. It's an estimated interest rate rule for the long-term rate, okay? So here you have the long-term rate, and so it's just a standard Taylor type rule with partial adjustment, allowing for an exogenous monetary policy shock, and without any without any zero lower bound, because again, the zero lower bound was not binding for the long-term rate. So the idea is to estimate this but allowing for multiplicative dummies for the binding ZLB period, okay? On those coefficients and potentially on those two too, okay? To see if there has been a change in the way the long-term rate has responded to, not to shocks now, that's what I showed you a second ago, but to developments in output and inflation, okay? Very good, so we do that. Now we face an issue which we always face when estimating rules, but here we can deal with in a way that we like, which is the potential endogeneity, okay? We still want to interpret this error term as an exogenous monetary policy shock, the way we usually interpret the residual or the disturbance in these monetary policy rules. So then there is a potential endogeneity. So what we do is to estimate this rule, but using the non-monetary shock component from our previous VAR. Okay, so from each variable is the sum of 4 components associated with the 4 different shocks, where we remove the component associated with the monetary policy shock, and that's the component that would be correlated with this disturbance, okay? And again, so conditional on our identification being correct and so on, the other components of inflation, the long-term rate and output would be uncorrelated with this monetary policy shock, okay? Because the shocks in the VAR are orthogonal to each other, okay? So we ask the question, did the binding ZLB constraint affect the response of the long-term rate to output and inflation developments? Okay, so here you have estimates of this simple rule for the long-term rate, and I guess the interesting part, first we estimate the rule with inflation only, focusing on inflation, and this is the coefficient on the dummy, the multiplicative, on the product of the ZLB dummy and inflation, okay? And see, it's not significant, okay? The coefficient on inflation is positive and large, well above 1, okay, in normal times, okay, and it doesn't change during the binding ZLB period. Here we also introduce output, okay. Oh, and here these 2 different values depend on whether we allow for dummies for the other, say, not so interesting coefficients in the rule or not, okay. And here we introduce output, and again, very small changes. Here, this is significant and in the expected direction, in the sense that it suggests that the long-term rate has responded less to inflation during the ZLB period than in normal times. But look at the magnitude. Okay, it's very small compared to the coefficient in normal times. So it suggests a decline in the size of the response, but a very small one. Okay. And again, for output, it's never significant. Okay. So again, this is additional evidence suggesting that somehow the Federal Reserve during this period managed to steer the long-term rate the way so that it responds to developments in the economy in the same way it would have responded in the absence of the zero lower bound. Very good. So here is a simple attempt, and not particularly original. A similar story has been pointed out by other authors to reconcile the theory and the evidence. Okay, so it's a simple way of introducing forward guidance in the model. Okay, so here we have, again, the model is the same, the basic new Keynesian model, and we change the rule. So now the policy rate is the max of 0 and some shadow rate. And so this is what we call the shadow rule. Okay, and the shadow rate is a weighted average of the target interest rate, okay, but not of the past policy rate, but instead of the shadow rate itself. Okay, that means that even if the target interest rate is positive, okay, because the economy has been recovering, inflation and output are, take normal values, to the extent that the shadow rate, the lagged shadow rate is negative, the current shadow rate will still be negative, and hence the actual policy rate will remain at zero. So the policy rate, the actual policy rate will remain at zero even if the economy has recovered from the recession that may have led it to hit the zero lower bound, okay? In a way similar, and this is anticipated by agents, so it works very much like forward guidance. It's a simple way of introducing a forward guidance element in monetary policy, okay? So we do the same thing.
Why is it related to forward guidance?
Well, because agents, if the economy enters the zero lower bound, enters a recession, a large recession, and the policy rate hits the zero lower bound, agents anticipate that the central bank will keep the interest rate at zero for longer, okay? Even after the economy hit.
That there's something moving that isn't showing up directly, but it shows up in the expectations.
Yes.
That's in that sense.
Yes.
But it doesn't have the element of commitment or communication.
No. Well, there's an element of commitment because this is the rule and the central bank will follow this rule. We're not allowing it to deviate from the rule. It's just, there's an element of commitment. It may be ex post suboptimal to stick to this rule, okay? But we're not getting, it's certainly not meant to capture an optimal rule or anything like that. And here you have the same impulse responses as before. So the economy is hit by an adverse shock. In red, you have what happens, the responses in a binding ZLB period. In blue, if the ZLB is not binding. In both cases, you see, the central bank cannot adjust the short-term rate when the ZLB is binding. It lowers it aggressively when the ZLB is not binding. But there's a result of this change in the rule. Now the response of inflation and output are very similar across the two regimes. And the long-term rate now responds in the same direction. It doesn't exactly match. We didn't want to tinker with parameters in order to get an exact match. That's not the point, but it certainly moves in the same direction now. So even though the central bank cannot lower the short-term rate, it can still lower the long-term rate in the right. Okay. And these are the relative standard deviations that I had shown you first for the data, then for the model with a standard rule, and now with the model with the shadow rate rule. And you can see that the ratio of standard deviations between the ZLB and the non-ZLB period is now much closer to 1. Okay. Now in this case is significantly above 1, but not much. And when we run these volatility regressions, again, we get, again, this is the key coefficient. So in three cases, it's insignificant, the coefficient on the ZLB period. In one case, it's significant, but it's relatively small. Okay. And this is the percentage of times in which we would reject the null of no change in volatility. And again, compared, it's much smaller. I mean, except for this case, it's very low and much smaller in all cases than in the basic model. Okay, and here you have again the same picture I showed you earlier for the model with the standard rule, but now with the shadow rule, and you can see that the differences in volatility are much smaller during the ZLB period. So that's I don't know if I'm beyond my time or if I have plenty of time.
Just in time.
Just in time. Okay, wonderful. Okay, I didn't know whether I had started at 5 or 5:30. Okay, so let me just conclude. So the question that we had put forward originally is how binding has the ZLB been in practice? Okay, And how effective have unconventional monetary policies been at getting around the ZLB constraint? Now, we have, it's important to emphasize that we haven't provided any direct evidence that these unconventional monetary policies have done the job. Okay, our evidence is indirect and based on the behavior of the long-term rate. So to the extent that you think of QE and forward guidance working through the long-term rate, our evidence is consistent with the idea that they have been very effective. Okay? So again, no evidence of an increase in volatility during the ZLB period, little evidence of change in the response of macro variables to shocks, little evidence of a change in the response of the long rate to macro developments. This is consistent with a shadow rate rule, but at odds with the predictions of a baseline new Keynesian model with a standard Taylor type rule truncated at 0, and overall support for the ZLB irrelevance hypothesis. The Federal Reserve, again, seems to have succeeded this time around in getting around the constraint imposed by ZLB. Now, one question that often arises at this point of the presentation is, well, maybe fiscal policy may have, or there may be other factors, okay? Of course, why should it be just monetary policy, no? And fiscal policy is a potential candidate, no? However, if you think about our empirical evidence, in particular the impulse responses, the VAR evidence, it is hard to reconcile with fiscal policy being responsible for the stabilization, because if anything, we would have expected the long-term rate to move in the opposite direction. I mean, fiscal policy may have succeeded in stabilizing the economy, but it's unlikely that an expansionary fiscal policy would have been associated, in response to the recession, would have been associated with lower long-term rates. If anything, we would expect higher long-term rates. Okay, so that makes us think that fiscal policy should not get the credit here.
But I guess you are saying that if the response of monetary policy is essentially the same in the long rate. Yeah, the long rate. And if it didn't go to 0, then are you willing to take the step of saying that the Fed could have done more to?
Yes, it could have done more. It could have done more in every single recession that the U.S. has experienced, and they didn't do more. They could have done more. They could have done. Yes, but that's not necessarily desirable. Even as I said before, because now why it's not because it may involve some risks of overreacting in some way, but in every large recession that we have seen in the past, the Fed and other central banks could have certainly done more. I mean, certainly in the ones in which the zero lower bound was not hit. But even in this one, in which the zero lower bound was hit, the Fed and the ECB and all central banks could have done more. QE could have been multiplied by 2, by 5, by 10. Forward guidance could have been much more aggressive than it was. Normalization of interest rates could have been delayed even more and announced. So for some reason, they chose not to be even more aggressive. Okay.
So I have probably a naive question. So it's about why there are not deflations. Why do we see not big deflations? Or is it?
No, we've seen a big response of output. We've seen a significant, maybe not as large a response of inflation as negative response of inflation but given the size of the shock, that's what you would expect.
Yeah, but I mean, isn't it natural? I mean, if I'm a seller of something and I see that prices are dropping like crazy, I would just stop selling and hope and wait till things get better. Yeah, I mean, and this is really what this. I mean, the OPEC can do that. Yeah, I mean, And I mean, even in the housing market, I mean, you try not to sell if prices are dropping. So it's really here on the supply side that the single agents can do so much that this will not happen. I mean, this might happen with the tomatoes, but not this long-term, long-term goods. I mean, goods that are not perishable. Yeah.
Well, that sounds like an alternative model, which you may want to show us one day. With a simple model, a very standard model, you would have expected much larger responses.
A behavioral model, I would clearly say it's simple to counteract inflation. I mean, this is different from inflation. Yeah, inflation, I mean, there you cannot stop that so easily because every seller will be eager. I went through
another paper.
Jordi, you mentioned before some work on another.
Oh, on Japan, yeah. It was not on this particular issue that Jim raised, but Shanglian Oh, one of our students who was on the job market this year, he repeated the exercise for Japan, actually for the U.S. and Japan, but focusing on the response to government purchases, and that's interesting because, as I'm sure most of you know, the standard model makes very different predictions for the response of the economy to fiscal policy, depending on whether you're at the ZLB or not. Okay, and for the U.S., he doesn't find any effect of a larger response to fiscal policy. Again, in contrast with what the model predicts during the ZLB period. But for Japan, yes. For Japan, there is a larger response. And one interpretation of this is that, well, Japan didn't really engage in unconventional monetary policies until much later. Okay, because in the case of the U.S., it was immediate. Once the interest rate hit the zero lower bound, but not Japan. So I think an interesting exercise that maybe that someone should do, is to repeat an exercise like this for Japan and see if there has been any difference, even within the ZLB period, before and after the Bank of Japan engaged in unconventional monetary policies.
But you could look for Europe, given that they raised interest rates somewhere, what would be side, and maybe it works for you.
The problem with Europe is that
they send the wrong message in those.
Okay, for the rule, we could do that. Now, for the problem for Europe is that, when we started working on this paper, I think there was just 1 or 2 quarters of binding ZLB. Not until relatively recently, the ECB has lowered the policy rate to 0, so the ZLB was not binding. Now we're accumulating observations, and we may end up having a lot of observations with a binding ZLB. But and then we could do something with Europe too.
Thank you, Jordi.
Thank you. Thanks.